heat balance, right? Heat balance. Heat balance equation is very simple. You get some heat from sunlight, right, every day. You also get heat from the ground into the greenhouse, major sources. Sometimes you can also get heat from indirectly from the structures inside the greenhouse, but there is a heat load into the greenhouse. That is happening continuously throughout the day when the sunlight is there. Also during the day and mostly at the night, heat is lost. Okay, so at any given time, if heat load is more than heat loss, then you have to cool the greenhouse. If the heat load is less than heat loss, then you have to heat the greenhouse, right? It's the what we call energy balance or heat balance equation. So you kind of asked this morning, how do you calculate cooling requirement, right? So it's very simple actually. If you look at sunlight, there's something called solar constant also, but it varies though. It's not a constant. It's a misnomer. It's not a constant. It varies by region, but you can take a value like 1350 watts per meter square, something like that. That's the solar. That's the amount of energy you're getting from sunlight. Okay. Thank you. Appreciate that. I don't want to sleep this afternoon, so I'm getting some coffee. Thank you. By any case, so sunlight is the major source of heat, and you get certain watts per meter square. So let's say your greenhouse is 10 meters by 30 meters. That's 300 meters square. So it's 300 meters square, and the solar constant, which is not a constant, let's assume that it's 1350 watts per meter. That's the amount of energy you're getting from sunlight. So you take that 1350 multiply by 300, you get something like 360,000 watts or something like that, approximately 353. That's the heat load. That's the heat load from sun, just from sun. The calculation related to the heat you gain from earth, ground, is even more complicated, right? But if you are able to calculate the heat load from sun, what you can normally do is you can assume maybe 15% of the heat load from sun is what is coming from the ground. So you add those two things, you get the total heat load. Approximately 90%, 95% of the total heat load you can calculate from these two things. And then you can now calculate the heat loss using the equation I gave you. From morning to evening, all you need to know is outside temperature and inside temperature. You just keep calculating the heat loss, and as long as the heat loss is less than heat gain, heat load, you got to cool the greenhouse. And those methods, different methods I've shown you, each method has its own efficiency. Usually, if you do that ventilation, natural ventilation, the formula I gave you, 10 CFM per square feet, if you do that, you will be able to remove at least 1x volume of air in the greenhouse every minute. Okay, approximately. Whatever the greenhouse volume is, you will be able to take all of that air outside, vent it outside in 1 minute. If you do that, you kind of maintain whatever the temperature outside is there inside the greenhouse. Okay, so these are a little bit complicated mathematical calculations. You can do calculations and you can figure that out, but the best would be to have a sensor and have a system and kind of figure out how much the system I should operate and measure the temperature difference. So again, it's all energy balance. Okay, heat gain, heat loss. Heat gain is happening from sun and from earth. That creates certain amount of heat energy inside, which raises the temperature of the air. If the heat gain, but then also keep in mind heat loss is happening naturally. Every day in the morning, more so in the evening, heat loss is happening. The heat loss depends on the difference between inside and outside temperatures, right? If it is very hot outside than inside, there is not much loss. Actually, we are gaining heat. It's all dynamics, but that's the kind of the big picture, this is the principle. Okay, but what I want you to do in this lab is this is your greenhouse. You are given this greenhouse. Okay, it's got some dimensions, right? A, B, C, D, E dimensions are there. I want you to calculate natural ventilation. So when I say calculate natural ventilation, what am I asking?
So you are asking about the ridge.
Yes, ridge and the side ventilation area. Calculate that for me. So I want you to draw a greenhouse just like this. But hold on, don't do anything because there's a lot of other things you have to do. That's very simple. But this is what I want you to do. Okay, you go down. Oops. Uh, this is from yesterday. This is today, right? All right. Okay, this is what I want you to do. Okay, calculate the area of the side and roof ventilation and show them on the greenhouse. Okay, calculate the exhaust fan capacity and show the fans, show them the location. Okay, and this will be open here, so you don't need to take a picture. I'll keep this open for you. Calculate the pad area and dimensions, also show them on the greenhouse, and the calculate area of the shade cloth needed for placing on top of the roof. Okay, and then once you're done, all of you do it separately, manually, no laptops today. Okay, just do manually. Okay, use a calculator. I want to make sure that those concepts are cemented in your brain. Okay, all right. If you have doubts, you can ask me. But do this calculation on a piece of paper. Nicely draw a greenhouse. Put the roof ventilation for the natural ventilation greenhouse, side ventilation. Also put the fans and pad area. Show all your calculations. I want to see them. Detailed calculations of above questions. Okay. Just take your time. We got plenty of time. And if you have any questions, ask me. But let's finish this fast. Okay. Sorry. Remember the rules of thumb I mentioned this morning for ventilation, fan specs, pad area, everything. So use that information. If you want to know the formula, if you don't remember the formula, let me know. I will again give you that information. But I hope you still remember. Again, keep in mind 15 to 20% for the ventilation, right? And for the fan, 10 CFM per square feet, right? For the cooling pads, you need to know the air velocity specification, assuming that you are using cellulose pads and use 250 CFM per feet for the velocity specification and calculate everything. Once you are done with these calculations, it will be very clear for you how to determine everything for a greenhouse, cooling requirements for a greenhouse. So ये कैसे रिकॉर्ड करेंगे आप?
sir.
Yeah?
Sir, in the citing, it was 15 to 20% of the greenhouse ground area.
Correct, that's the formula.
What we take the lower limit, the upper limit or the lower limit?
You can do either one is fine. You can go with 15%. But remember that 15% is for both sides. Right? The total area is for both sides. Okay, calculate 15%, divide by 2, one half on left side, one half on the right side. If you have any questions about the formula, don't hesitate to ask. Okay? If you want to know how to calculate, don't hesitate to ask. I want to make sure that all of you do that, those calculations.
Calculate the
Total what?
total area of the greenhouse
What are you using that for, total area?
for adding this all
So, yes, I understand you want to calculate, but why do you want to calculate total surface area?
because a side and the roof ventilation is 15% of the total.
The ground area, not the total area, right? See,
And ground area is the A and
correct.
only
Just A and what? Area, right? A is one length, and what is the other length?
B.
But hold on to that question because the next question, next activity will require that. But for now, it's only ground area, right? For cooling requirements, you go with the ground area, not the total surface. No, right? So just a hint, it may be very easy if you convert the meters into feet, right? Because most of the things I told you this morning, like square feet basis, cubic feet per minute basis, right? So it makes total sense. You convert, all of this is in meters, you can convert into feet, right? That will help you. But you can also do in meters if you want. You got to reconvert the values I gave you this morning. So how do you calculate fan capacity? Who remembers that? How do you calculate fan capacity?
10 into the total area.
So 10 cubic feet per CFM per what? Per square feet of area. But what I'm giving you numbers are in? So be careful there, okay? You may have to convert it back. That's why I'm saying all of these will become easy if you convert the meters to feet. Okay? Does it make sense? Sorry. One meter square is approximately equal to 10.76 square feet. You can Google that. It's not a big deal. But yeah, 10.8 approximately. 10.8 square feet. Okay? So you convert your area into square feet, the ground area into square feet, and then calculate the fan capacity.
Total area, sir, or ground?
No, ground area. Remember, the total surface area is for heating requirements, right? We're going to do that next. But for fan specifications, I said it's a ground area, right? That's what I told him too.
And sir, for the area of shade roof, we simply take the above square roof
Yes,
area.
yes. Sorry. You got for the fan, right? What's the next one? Pads, right? What do you want to know about pads? Do you remember what I said this morning? The formula for pads. Who remembers the formula?
Pad area is equals to the exhaust fan capacity upon 250.
The 250 is the air velocity specification, right? So you can use that same numbers. So go ahead and calculate the pad area and show it in length and height for the greenhouse, right? Has everyone finished question 1? Everybody finished question 1? Anyone still doing question 1? How about at the back? Finish the question 1. Okay. All right. How about question 2? Who is working on question 2 right now? You're working on 2? Okay. Good. Continue. Okay. Yeah.
So in this image, A1 is also a rectangle, no? A into let's see.
A1? Where is A1?
A only A. It is also a rectangle.
A is the length.
And C is the height of that.
C is the height. Right. So it's just one dimension. A is length, C is height, B is the depth. Okay. And then you have D, the height at the triangle. And then you have E as the length of that side of the roof. Okay. So it's just a length. Those are all length measurements. It's not area, it's a length measurement. Because if it's area, you will find meter square or something, right? Talk to each other, interact with each other, so that way you know what everyone else is doing. But if you have a question, call me, I'll explain. Okay. So how is it going for you, Mr. Kuldeep? Good. I see that you're doing math, so do ask me. If you have a doubt, do ask me. Okay, I will explain it to you. Pad area formula, exhaust fan capacity divided by 250. Air velocity specification is 250. But again, they are all in feet. They are not in meters. Everything here is in meters. Okay, so you have to convert them. 1 meter is approximately 3.33 feet, or 1 meter square is approximately 10.8 square feet. Yes, yes. So some of these people, they're out of the program, or they're not here, or
No, so मैं थोड़ी normally they are present. So Rohit, Kanchan, Karti, and Maninder. They call him.
so I want to understand why some of them don't come in the afternoons. Because in my opinion, afternoon sessions are more important than the morning sessions. You will get to learn more in the afternoon. I want to understand if there is any problem, we'll try to find a solution for that. That's all. Okay. I want to help. So let's find out why it is the case. It doesn't seem to be random. Yesterday also the same thing happened. So
सर ये भी तो फीट में आएगा फिर हम इसको मीटर में कन्वर्ट करें
you can convert in meters, or you can give me answer in feet also. Yeah. You have a doubt? Okay. Let's see. Ask me your question. 300 meters square, right?
I'm taken, sir, because you stating that 5 to 10 kilometer per hour meditation, so I'm converted it into meter per second.
Sorry, I'm confused. Why did you go to that number? 5 to 7?
Air velocity is specification.
That is 250 CFM, 250 feet per minute. But let's go back to, so you are now working on second question or first question? First question. First question is about area of the side and roof ventilation, right?
Actually, 1 to 5 all question are answered.
All are answered.
Yes.
So okay. So which is first one?
Area of side wind, sir. Actually, area of side wind was 20% of
20% of what?
20% of total area.
हाँ आगे पीछे नहीं, just ऊपर का. So 20% of what? 20% of where did you get 18 from?
Red area.
Well, see the area there. Area is what? A is what? A is 110 meters, B is 30 meters. So ground area is how much? So I'm going to go there and explain. So it looks like some of you have confusion with these numbers. Okay. What is the ground area here? A times B, right? Okay. Because that's the ground. It's a rectangle. Okay. So use that as a ground area, and then 20% of that will become the side ventilation and also roof ventilation, right? You can show it in meter square, you can show it in feet square, it doesn't matter to me, but that's important, okay? But then you use the same ground area for fan specification too. But the thing is, I gave you the fan specification in square feet. I said 10 CFM per 1 square feet. But here I am giving the numbers in meters. So you are getting meter square. So now you have to take the meter square, convert into square feet, then use that square feet and multiply by 10 to get the fan specification in cubic feet per minute. Okay. So I think that's what you have to do. I think your answers 1 and 2, maybe you have to change that. How is it going for you with this? You have any question, confusion, issues you want to ask me? You're good? Are going well? Okay. Well, I'm going to ask some of you to come forward and explain the answers, okay? I'm going to sit there and watch. So, better be prepared. I want to give you an opportunity to talk, right? It's important. So, did you understand?
Area of side vent
So,
will be
20% off.
300 meter.
Here I saw 18 meters square.
I'm so technical area, that's why.
So, when we get to pad area, so that's number 3. So, remember what is the formula for pad area?
So pad area
Is fan capacity.
yes.
How much did you get for fan capacity?
Capacity actually we get 3000 meter cube per minute.
Well, so remember, I'm going to write it for you. What? Give me your pen. I said fan capacity is 10 CFM per 1 square feet.
Yes,
But where is feet there? It's all in meters.
yes, yes.
You have to convert it to feet first, right? I'm going to make it smaller. I'm coming. Yeah, yeah. That area and that area. So twice that, right? You can assume that it's a polygon. If you can Google out, you'll find the formula. Everything is on Google, so I just don't want to tell everything to you. Imagine this is your situation, okay? You are a greenhouse consultant, and your farmer has a greenhouse, and you have to give a recommendation, right? Right.
For the fourth one, which you are saying it is a polygon, but we have to cover only
The sides.
two rectangles. There are two rectangles.
Well, it's kind of polygon, not rectangle, right? So yeah, you cover that side and you cover this side, right? Top.
Area of this rectangle and plus
Just make it twice. If you can find one, it's a simple thing.
simple length and
Sorry? Yeah. Yeah, length. Yeah, very simple. So let's go back. So what was the question we were talking? So this is what I told you, right? Now I want you to convert that, right? Convert and then give me the answer. आप खत्म किया all 4 हो गए. Okay, very good, very good, very good. Let's see. All 4 done. Okay. How about you? All 4 done. Okay. How about you? All 4. Are you looking at the third? Okay, go ahead. How far are you, this group? You have finished the first and the second one? Are you working on the third? Which one are you working on? The third one? Okay, number 3. Number 3. How about you? Did you finish all 4? Or are you working on the you finished just the first one? Okay, second one then. Work on the second one. You're working on the third right now? Third one, right? You're also working on the third? Okay. Okay, we will give some more time because some of them are working on number 3. Here they're working on 3, and you're working on number 2. So maybe another 10 more minutes. Okay, you are also working on 3, right? 2 or 3. So what is your question? Ask me your question. Where are you finding it difficult? Why don't you discuss amongst, you are one group, right? Here you're one group. So why don't you discuss amongst 3? And only reason is my Hindi is bad. मेरा हिंदी बहुत अच्छा है. So इसलिए you have to talk to them. So they will explain to you. But why don't you all 3 work together? And why don't you ask your questions? This is called peer reviewing. Okay, you're all peers among yourselves. Yeah.
So for the third one, the exhaust fan capacity should be divided by 250 square feet.
Right. For the third one, the formula is fan capacity in cubic feet. Right. Fan capacity should be in cubic feet. Right. That much. That is amount of air that you want to see from cubic feet per minute. Right.
Cubic feet should have to be volume then. Cubic feet.
No. Remember the formula. What is the formula I gave you for every? I wrote it here. You see, 10 cubic feet per square feet of ground area. What is your ground area in square feet?
32291.
So that is 300 times some 10.8, right? That's your ground area. 10 CFM per square feet, but you have 322 whatever that is, that many square feet. So you have to multiply that number with 10. That gives you the fan capacity in cubic feet per minute. Okay, take that number, divide that by air velocity specification, which is 250 CFM per minute. When you do the division, you will get in square feet for the pads, right? Does it make sense?
Yes, sir.
Do the calculation, but first convert. So what is
12.9.
that's the area you got in feet, in square feet. Pad area is 129 watts.
Feet square.
129 square feet, right? That's what. Then that is the total area. Okay. How do you put that area into the greenhouse? Where are you putting that pads? On that side, right? Think about the width. You see what I'm saying? You have to now put that area onto one of the sides. So you have to determine the length and height in that area. You can get as close as possible, but get to that. Yeah.
1 to 15 के बीच में 15%
Okay. Where are you stuck?
I don't know how to calculate this.
Did you finish for the first one? So it is 15% of 300. So it's 45 meter square should be the area of the side ventilation and then the roof ventilation. Now I want you to draw this. Where do you put that 45 meter square? So if it is 45 meter square, you know, half of that should go on the left side, half of that area should go on the right side, right? Right. So you have to put that ventilation. Usually, yeah.
ये साइड वॉल्स है और ये गेबल ऊपर के रूफ का ट्रायंगल.
साइड वेंट और टॉप वेंट. साइड वेंट के अंदर में कुछ दो नंबर होता है. दो नंबर
Yeah.
If you are calculating the area for side vents, we're taking the 15% value of the area total.
Right.
Then that will be the same for the roof ventilation.
Right. But for the side ones, you're going to divide into two because for the left is one half, the right is another half. And I want you to show that in the dry greenhouse and show me that length. I want you to calculate length and height to get to that area. Let's say you got 50 meters square or something like that for the side ventilation. 25 on one side and 25 on the other side, right? Now, how do you show the 25 meter square? The greenhouse is what? The greenhouse is 30 meters long, right? So you may want to create maybe 15 meters by 2 or something, right? That gives you ventilation area. I want you to show that on a picture, on the side picture, right? So finally what I want to see is the design of the greenhouse, right? Does it make sense? Right? Is there any way I can actually, there is no board here, right? Can I use on that?
मैम पेन
This is a
करना
touch screen board. There is a pen for this one.
Is there a pen in there?
Pen will last. They can arrange.
Oh, there is a pen over there. Stylus. Let's see if that. So I may have to create a notepad maybe.
Website, something like this.
Yeah.
Maybe try drawing something now. Yeah, you are in innovation mode. Yeah, you can just start drawing.
Show here itself. Okay.
Yeah, you.
That's good. That's good. Where is the eraser? Yeah. Okay. I'll wait some more time and then I'll show you on that. Okay. But give your best shot. You got another maybe let's say 10 minutes. Try to do as much as you can in next 10 minutes and then I'll show the answers. Okay.
So what is the optimal place to place that cooling pads? Like it has to be closer to the ground, or if we have got the area, we can put it in a bit center.
The cooling pad should be at the height of the fans, right? If the fans are here and the pads are there, oh no, they should be similar. And you don't put the fans on the ground level. So ideal would be approximately you leave 5 feet from the ground and then put your fans there. Same with the cooling pads too, about 5 feet. Okay. Yeah, but the good question. Yeah, I didn't cover that right when I was teaching. Yeah. So I'm saying that there are 4 teams. Okay, team 1, team 2, team 3, team 4. Each of you should take one question, stand there and explain to others how you got an answer. Okay, you pick up whatever you want. 4 questions, 4 teams. It doesn't matter. Team 1, team 2, team 3, team 4. All right, who wants to do question 1? Team 3. Come on. Team 3. Explain to us. You are the leaders now, okay? You are the teachers, we are students. That's it. Stand there, take this opportunity and explain with confidence. Discuss amongst yourselves, teams, other teams, what questions you want to deal with. Okay. It is okay to make mistakes. Okay. It is totally okay to make mistakes. We all make mistakes. I make mistakes. Okay. It's okay to make mistakes. So please stand there. You have a pen there. Okay. You have a pen, that black pen. On the side, you see that black pen? And there is an area up there you can use to write your answer and explain it. And you see here, right now it is on, I'm also learning, so please bear with me. So this is the pen. So I think you have to select this one up here for the pen, okay? And then when you, and maybe black color, okay? Black color. And then if you don't like what you've written, you can, this is the eraser. That's the eraser, okay? Pen, black, eraser, okay. Now go ahead and show your answer for question 1. All right, folks, let's listen to team 3. Let's see how they got the answer. I'm standing way away from you, okay? So I can see you. So please explain as you are.
The first question, we have to calculate the area of side and roof ventilation. So first of all, we have to calculate the floor area. That would be this thing, floor. A into B.
Okay.
And A is about 10 meter and B is 30. So total floor area will be 300 meters square. And if we will calculate it in square feet, it will be around
3227.
Well, let them first finish it, and then you have a dispute, you can raise your hand and say the dispute. But let them finish first. So 3240 square feet, right? Is that what you got? Okay.
This will be the floor area.
Okay.
And on an average, the area of site is around 15 to 20%
Of that value, right? Of that floor area.
Yeah, of floor area. 15 to 20%. That is up to us. So we are taking 20%
Okay.
as side area. So it will be around 300 meters square.
Are you doing in meter square or square feet?
To make the calculation easy, I'm taking
Meter square. Okay, that's fine.
Afterwards, it can convert. 60 meters square is the side area.
So what side is it? Is that left side or right side or both sides?
One side. That the side is for two side.
Right. So where are you? So on that picture, the greenhouse picture, show me where you want to put your ventilation, side ventilation. So why don't you use the eraser and strike off the black lines you put on that image right there, right? But now show me, yeah, take that off. Now show me your area where you want to put that ventilation. So if you are putting a window, it should be a rectangle, right? It should be a rectangle. So they are trying to fit you should fit a rectangle, right? It's a ventilation, it's a window, right? So you want to draw a rectangle on both sides, right? It should be the same area, but you determine that 60 meters square is the total area. You got to divide that 2, 30 meters square on this side, 30 meters square on that side. Now 30 meters square means what is the length of that B? Yeah. So what are the dimensions then for that window? 30 into 2 is 60. No, we don't want 60 on one side. We want 30 on one side, 30 on the other side. So how do you do that? So 30 meters square on left side, 30 meters square on the right side, right? Now show me how do you put 30 meters square area on this side and 30 meters square on that side. These on both sides. So you have to show that number. So how do you get to 30 meters square? Right, that's correct. But I wanted to show that window area on that picture, I want to show the length and width of the window, or length and height of the window. This is interesting, right? This is how you learn more. You will learn more when you put yourself in front of the others, ask them to challenge you. You will never forget whatever you learned at the time. Okay, this is an important learning lesson for life. Remember this. Okay, what I don't know what they're doing, but we'll get to that. The time for queries is over. You'll stand there and explain. It's okay. Take your chance. Challenge yourself. You are a team 3, okay? You're going to go stand and do that. Likewise, you are a team 2 and you are a team 2. You're team 1, okay? I don't know what question you're dealing, but it's up to you. All right. So what I'm asking is, you know the area to be on the left side, you know the area to be on the right side. I want you to show that area on the picture. What does area means? Area means you have length and height. So show me that window, length and height. What is that length? If it is 30 meters square, and if your one side is 30 meters, what is the length and what is the height? Okay, very easy right here. I don't want to give you any more answers. So 20 by 10 is what? 20 watt and 10 watt. 20 meters or feet? So 20 meters by 10 meters is what? So but again, yes, that's the best design, right? That's the best design, right? 30 times 1, because you get the entire length of ventilation, right? Easy. You can do 15 by 2, you can do 10 by 3, that should be 10 by 3 by the way, But best model is have the ventilation all along the greenhouse. So that way all plants, wherever they are, they get some cool air. So show me 30 by 1 then. 30 meters length by 1 meter, 30 times 1 is 30 meters square. That's what you want to put, right? So all along that length you get this. Yeah. No. Let me draw it for you. I think you will get it when I draw it. So let's see here, right? So what I'm trying to say is you can put 1 meter long high window and then 30 meters long. What is the 30 times 1? 30 meters square. And you have to do the same thing here. 1 meter height and 30 meters long. Why 30 meters long? Because B is 30. B is 30. See that? So now you created a ventilation. Right? But then when you get to the roof ventilation, you have to create something like this, right? At an angle of 60, that's correct. That angle is 60, right? That angle is 60. But this area should be 60 meters square, right? What is that length? That's again 30. So now what is this? This will be, so this is 30 meters. This should be 2 meters. Understand now? So when you draw it, you visualize it properly. Okay? That's question 1. Okay? Alright? Thanks for doing it. Very good. Thank you. Alright, we're going to erase this. Everybody understood this? Any questions before I erase? Do you understand? You did not understand the upper one? Okay. What is the formula for this roof ventilation? 20%, right? Either you take 15 or 20%, they took 20%. So 20% of 300 is 60 meters square. So I need to show 60 meters square for that ridge vent. How do you get 60 meters square? You already know that this one, okay, let me erase it, right? So you know that distance from here to here is what? 30 meters. You see that B is same as that, right? So already the length is given to you. You can't get more than that. That's it. 30 meters is the maximum. But I want 60 meters square. So one length is 30 and then what should be the other width? 2. 30 times 2 is 60. So this will be, then you create a ventilation here like that, right? So this is 30 and this will be, oops, that small thing, that will be 2 meters. It's a flap. That's what 30 times 2, 60 meters square. All right. Okay, good. Let's get to question number 2. Who has decided? Who is doing question number 2? All right, come over then. All right. Calculate the exhaust fan capacity and show the fan location on the greenhouse. Okay. Okay. All right. So they are doing number 2, and if you have any doubts, you can challenge them. Okay. All right. Go ahead and explain first.
Okay. So, firstly, as we saw in the question number 1 case, they calculated the total ground area.
Right.
And I've got that area in square feet like they converted in the last.
Right.
What they did for generalization was they took 10.8 as the value to convert it into the feet, but I took the quite accurate value to the 4 decimal point, 10.7346. So I got a better estimate of around 3274, or let's say 275. This was the actual area in square feet of the ground area of our, what we say, greenhouse.
This is 32,000 square feet. Oh yeah, you may be correct. Yeah. Okay, got it.
that's the thing. Now this is the area, the ground area for the greenhouse. For the fan capacity, it's very simple. We just multiply this by 10, and we'll get the total CFM cubic feet per meter.
No, hold on. There is something wrong there. 300 times 10.8 is not 32,000. It is 3,000 something.
That I wrote is the CFM.
Yeah. Well, you're putting square feet, and how can you say it's CFM?
Because I calculated that on the paper.
I understand.
They both are same actually. Now only single decimal point difference.
No.
T02 3227.45. So that is the actual area, ground area.
Square feet. Put units, please. Always put units. Otherwise, people won't understand. Okay.
So this was the area.
Ground
Now
area.
when we multiply this by 10,
Okay.
we will get the fan capacity.
So 10 for what? 10. Put the units for 10. We want to be very, very accurate, right? We need to understand what are the units of 10. 10 what?
Cubic
Cubic feet per minute.
per minute.
Per what? Per square feet. Okay. Otherwise, they won't get cancelled. I want you to show me also how you got square feet, right? How do you write cubic feet? Feet cubed. FT cubed. Right. So if you multiply, right, that's the CFM you want. Okay. Everybody agree with them. They are claiming that 32,000 CFM. But are you going to just stay with that, or I said something else? Remember? Yes. Add always 10% more for inefficiencies in the system. So you can round it up to 35,000. Because you go to the company and say, I want 32,274 CFM fan. They are like, we don't have that fan. They may have a 40,000 CFM for you. They may have a 35,000 CFM for you, right? The fan companies do like, so 35,000 rounded it. Okay, that's the fan capacity. Where are you going to put that fan? Is it one fan? Two fans? What is that?
So for the next part, I would like to call my
member
and ma'am to come and explain.
Okay, then just put that number 35,000 at the top, and please show us how many fans and where those fans are located.
We can use 2 fans.
Okay.
And location will be.
So they are using 2 fans, and what is the capacity of each fan? 17,000, 18,000 CFM, right? So you go to the market, and if you don't find 17,000, you might find 20,000 CFM. It's okay, buy that one, because you may not find exactly.
15 to 20.
Yes, exactly. You may not find the same specification you need, so you may have to adjust. But there is one important piece here. How far apart those fans should be is an important question. Please, all of you. She drew 2 fans, and she's telling us that approximately 20,000 CFM for each fan. But are you going to put those 2 fans together? Are you going to put them away? What is the distance between them?
Approximately, it is divided by 4 and 2.
So you have 10 meters there. So you have 10 meters. That means you have approximately 30 feet. So what I'm trying to tell you is that you should at least maintain 20 feet between the fans. 20 feet would be how many meters? 6 meters approximately. Approximately 6 meters space between the 2 fans. So if it is 6 meters between the fans, and each fan is 1 meter wide, that's 8 meters gone. So you got 1 meter on this side, 1 meter on that side. So let's draw that one and show to everybody. Please watch this. She's actually putting the design there. Okay? Or you can draw a bigger picture if you want to. So you actually have some space all the way up to here, but that's okay. I think you explained. So 1 meter on both sides, and then the fan itself is 1 meter. She has got 6 meters in between, so that gives 10 meters. That's how you have to design. Or he wants to show it this way. See now. And the fan itself is 1 meter. That's 10 meters. You got it? Okay? That's how we design. Okay? All right. Great answer. Good job. Good job. You also did very well. Okay? Who is doing question number 3?
We would also like to thank Prakash and Gautam there during
Of course. Of course. Please. Thank you. Thank you. All right. Who is doing question number 3? All right. I'm going to take my coffee from you from over there. If you want to take some tea and then maybe take a 5-minute break, that's okay. Or if you want to work parallelly, that's fine too. You can erase it.
No, sir, we'll require this one.
You
For
can.
the next question.
Yeah, but we know the answer. So what are you going to take? Just write that number at the top. CFM. Whatever you're going to use. You're going to use 35,000. Okay. All right. So you can erase the rest of the stuff because you got to use that space to draw things, right?
So for calculating the pad area, we'll divide this fan exhaust fan capacity by the air specification velocity. So it would be around 35,000 divided by
35,000 units, please.
CFM,
Yeah.
or we'll simply
I would write CFM.
feet cube.
Yes, more scientifically. Cubic feet per minute. Okay.
So we'll 35,000 feet cube divided by 2.
No. That's just cubic feet. Cubic feet per minute. You are not showing minute. Right. Okay. That's those are the units. Units are very important in science. Units should cancel out exactly the way you cancel out your numbers. Okay. What are the units of air velocity specification?
Feet per minute.
Feet is feet per minute. You are correct.
Per minute, so we cancel. So it will be feet square.
And minute gets cancelled.
To this, so the area will be 140 feet square.
140 square feet. Okay, that's what they got. Any questions so far? Everybody agrees? Everyone, team 4 agree? All right. Okay, now they got 140 square feet, and now they are going to show that 140 square feet on which side? Please show me where fan should be. Fan should be on what side?
Fan should be on the leeward side.
Leeward side. So they already put fan, so that is your leeward side, and this is your windward side. Okay. So now you can erase all of this, and I want you to just show the pad area.
Sir, also one more thing. We have got the area 140 feet square. So to calculate the width or the height is around 4 feet. We assume the height as a 4 feet for the pad area. So we calculate the length. So the length would come out as 35 feet.
But do you have 35 feet there? You have 33 feet, right? So you may want to increase a little bit, or you can still keep the 4, because you're not going to get a customized pad height. They either sell it as 4 feet, 6 feet, or 8 feet. That's it. So you have to stick to that. Therefore, you reduce instead of 140, you may get a slightly less area. So your pad is 30 feet long or 33 feet long by 4 feet. That's it. Right? Does it make sense?
Also, we are taking these as a big number because 35,000 is which we took the.
Correct.
If we take it by 32, we'll get it.
You may be able to fit it. Yeah. You may be able to fit it.
So sir, we'll place
Yeah, can you erase all of that and show us nicely? Well, is that correct? Where are you putting the pad? What is the side?
Sir, on the windward side.
So, okay. Their intention of fans is at the back. You see what I'm saying? They are not putting the fans on the side. That's where the fans are. You see, the reason why that is a little bit confusing is that they draw that line to that. You see what I'm saying? Piche, back is the fans, front is the pad. So your pad should be on that length of A. Now, Ms. Ruchika Chaudhary, please let me help you. Show me the length A. Where to where is A? Yeah. So what is the length of that A? How many meters or how many feet are there? Or 33 feet approximately, right? That is the side on which the pad is going to be. Because the fan is going to be on the back side. You want to show the back side. I think he understands. So let him do it. Erase of everything if you want to. You can also draw the fans again if you want, okay? Because that fan is a little bit confusing, okay? Take erase of everything and now show the fan. पूरा पूरा erase कीजिए वो red वाला fan है ना उसको पूरा erase. Now please draw the fans. I think let me come over there. I think it's just it's a three-dimensional thing that's confusing. Okay, so remember this is the back side, right? Am I doing it right? Okay, this is your front side. You see now, front up to here and the back. But you were thinking of the side length, which is what, 30 meters? No, that's not. We are looking at the front and we're in the back. The fans are here. 1 meter there, 1 meter there, 6 meters there. Now your pad should be on this side. Okay? All right, now you understand. Go ahead and draw it. It's just the three-dimensional picture is not clear. That's all. So you got 140 square feet, isn't it? Or 140, what was that square feet, right?
140.
What is the length and width then you want to go for? Approximately, whatever that is.
So we can take around 33 feet.
But you don't have 33 feet. Yes, you can take 33 feet. Yeah. So when you are taking 33 feet, then it should cover the entire length of A, right? Huh. At the same height as the fans. So remember the fans and pad should be approximately the same height. Yeah, there you go. But what is the length and what is the height?
The height.
4 feet. So show that 4 feet and also show the 30 feet. That is 4 feet. And the width is 30 feet, right? Okay. See, this exercise is important. Any questions on what they have done? Do you all agree? Or if you are not understanding, this is the time to ask. because once we move out of this chapter, we're not coming back.
So can we put the that fans on the any other side also, or we have to take on the backward side?
People also put the fans along the side wall, but again, it goes by the leeward and windward side. If you are going to have a leeward side on the side of the greenhouse, that's where you can put your fans and pads, windward side. It goes by leeward and windward side directions. You need to know which side is wind coming from and which side is wind going away. And if your greenhouse is perpendicular to that, yes, you can do what you just said. Okay. Any questions on this? Everybody understands? Team 4, do you understand that? Do you understand that? Yes? All good? Okay. You go, then your stage is yours. Question number 4.
So, gentlemen, as we have to find the area of shaded growth net, so we have to calculate this area. And the same side we have the this area. Simply, as it is a polygon, so we can assume that it is a rectangle. Okay. So E is 7. 21 meter square, and it will get multiplied by 2 because there are two sides.
Okay, so this is an easy one, right? So I'm going to give a little bit more challenge to you because it's easy, right? And while they are doing, I want all of you to do. Now calculate total surface area of that structure. You know what total surface area is now? Not ground area. I want the total surface area. This is what you will use for heating requirements. So go ahead and calculate total surface area. Add everything and show it for me.
Gentlemen, we have this side. We have to calculate now this angle.
Well, why don't you do the math first and then explain to everybody? First, because you have not done it right so far. So why don't you, as a team, come together and do the math? Help him with calculators and things like that. All of you also do the total surface area calculations. You got 1, 2, 3, 4, 5, 6 sides. Well, 4 sides, but you got 2 triangles, and then top. So 8 in total. 8 distinct. Yes, the whole sides and the top, everything except the ground area. Okay, except the ground area. By the way, this is the easiest for calculating the total surface area. If you have a curved greenhouse, it's even challenging. Sorry?
7,999 square feet. I did it firstly only.
Okay, then you have to wait and confirm whatever the. I see you did the mistake then. Okay. Well, let's see if that number is correct. Let them come to it. But if you have not done it, please do it again. Yes. And also this side, and the height, right? Everything. Yeah, all sides. It's not just this. It's like और ये sides भी है ना पूरा. Yeah. It's very easy. You only have rectangles and triangles there. But think of a curved roof. That will be the homework for all of you. Okay. Because you have already done, why don't you attempt the formula for the curved roof? I don't know, but you try to attempt it. You know the curved roof. I just want the formula. You can take back away. You have any questions for us? We're all doing fine. Yeah.
I just wanted to make a
Sure, please.
Yeah. Tomorrow we'll have photograph session. So please be prepared and be ready.
Sure. Come in your best dress, tie and everything, you know.
Common uniforms you can have. Same color combination. So boss, you as well.
Yes, sure, sure, sure. I will come. Thank you. Appreciate that. Yeah.
So I call each and every student for everything.
You have called them. And what was the common
They
reason?
told me they are present from tomorrow. If they are not present from tomorrow, so I will take that day.
Okay. They didn't give you any reason?
So feeling sleepy, feeling tired.
Okay. I mean, I should feel tired, right?
Yes, yes, sir.
I'm 50 plus and
Yes, sir.
I'm standing there for hours and you're youngsters.
Sir, 840.
You have a question? You have the answer actually? Question. Okay, go ahead, please. Fire away.
So first of all, we have to see the windward areas, and after that we have to decide the side areas. Or we can put in the pads and the fan area beside the side area only.
So, if you have an open plot, you have a lot of flexibility, right? A big plot, there is no obstruction. Then you go there to that region and figure out what is the common direction for the wind in summer, because you are trying to figure out for cooling requirements in summer. So there is a specific direction of wind in summer. Okay, so monsoon comes always from south. What is that? Southwest, right? Southwest monsoon, right? So the wind is coming in the southwest direction. So you have to align your greenhouse in that southwest direction if you can. Okay, and if you do that, then you put your pads on that side, fans on the opposite side. But sometimes you don't have that option. If you want to turn it this way instead of like length like this, you turn it this way. Yes, of course, the wind comes through the side and it goes away from the other side. That's good for natural ventilation. But if you want to do fan and pad, you have to put how many fans? A lot of them on that side, right? Because it's not 10 meters, it's now 30 meters. So you have to divide 3, 4 fans. If you just put one fan here and one fan there, the middle area will be a large area and you will create a heat pocket there. So it will be better to actually have the fans on this side. I'm sorry, fans on that side, pad on this side. The fans and pads on the shorter lengths.
We have told for all the walls. Here we have placed side area. We have placed 2 windows.
Correct, correct.
In front of this we have that pad.
Yeah.
This side we have fans.
Yeah, and if you are going for a fan and pad, I think you asked a good question. Yes, please. Yes, please. And I'll explain to everybody later. But if you're going for a fan and pad system, no need for side ventilation. No need for side ventilation because you create open area, then you're losing the efficiency. You have to just pull all of the air through the pads. But if you're pulling through the pads and you open the side, hot air will come from the sides. So you don't want to open that. Okay? Good question though. But I'll explain to everyone else. I think I missed it. That's the reason why I want you to ask questions because I may not be able to cover everything. Right?
That is
You got it? So what is the answer?
840.
840 meters square. Agreeing 840 meters square. 840 meters square. Who else got the 840? Did you get 840 meters square? They are doing it. Okay. I think it looks correct because a couple of you come. But one thing. Thank you very much. Come down. Yeah. Why don't you erase that and come down, please? Uh, so there was a question from team 3. From team 3, they want to put a fan and pad system. Okay, and they also want to have a just an example. Okay, and not that you want, but they also want to have side ventilation. Can we do that or not do that? So what they are asking is they want to design fan and pad system, the fan on one side, pads on the other side. Okay, but they also want side ventilation and roof ventilation. Is that good or not good? You have fan and pad system, but in addition to that, side ventilation.
We can add, we can combine two methods to improve the cooling process instead of depending on one.
Okay,
So the base.
but my question is, can you open side ventilation, open the ridge ventilation, and also run fan and pad system simultaneously? Why not?
Sir, so because we won't be wanting that air would be moving from all the directions, so it would be difficult to control that. Instead, we want
top ridge works by creating the negative pressure on one side. When there will be air moving at a very fast pace, that process won't work and will stall.
Not exactly. You have an answer? Yes.
Because if this both side ventilation is there, there is no use of controlling air. Cooling.
So when you are running fan and pad system, where is the air going through?
Sir, air is.
You are pulling air from the fans, but the air is coming in through what? Outside is coming into the greenhouse, but it is coming through what? The pads. Why pads? Because pads have got water going down. But if you open sides, what happens if you run the fans? The air comes from the side into it, not through the pads. You get hot air inside. You have to create air tightness. Only the air should come through the pads for the cooling effect. That is the reason why. Okay? But good question though. Okay, 4:40. All right. Do you want to discuss or you are tired already for the day? It's your call. I'm fine. Huh? Never tired. Never tired. Okay. What about you? I was trying to actually do the heating calculations also today, but I think we'll stop with cooling calculations. You know how to calculate total surface area now, right? It's simple afterwards. Q is equals to U, plug in that number, times A, which you calculated, times W wind factor, that number is constant, and Ti minus To, you know that. So it's not a big deal, okay? It's not a big deal. So we'll leave that there. Cooling is important. Today you become a professional designer, right? You are able to design an appropriate cooling system for the greenhouse. You are able to design the right type of fan capacity. You are able to design the right size of the pads, not just designing the numbers, but you are actually able to put them on the greenhouse. Show those things on the greenhouse. That's what exactly is needed. Okay. I talked about this in the morning class, but unless you did the math calculation in the afternoon, you didn't get the concept cemented in your brains. So tutorials are important. Please tell your friends. If they are interested to learn more, get the concept cemented, tutorials are important. They are designed for that, exactly. Every chapter has a tutorial for that. The reason why I put these things is with a lot of experience. I've been teaching this course for 7 years, 8 years to students. I know where they get into problems. I know where they get into trouble. I develop the tutorials based on all of that experience. And if your friends are not attending, they are losing the opportunity. They are losing the opportunity. Tell them, bring them all. Okay. But in any case, for tutorials part, we are done today. Now, if you want to leave, you are welcome to leave. Okay. But if you have any questions, you can ask me. I'm going to stand here until 5 p.m. Okay. They pay me until 5 o'clock, so I can't leave. I'm just kidding. No. Go ahead, ask me. If you have any questions, you can.
For the curved one,
Sorry.
sir, if we have a curved roof
Uh-huh.
that you were telling.
Well, he was trying to calculate what. So, all right, take it as a challenge, homework. Okay. This one is sort of like an A-frame, easy. But if you have a curved roof, okay, the roof is what? Curved, not A-frame. What type of formula can you come up with? Can you? I don't know that. You come up with a formula and give me tomorrow. Area is equals to this formula. Yeah, height will be D. Yeah, yeah. Okay. Use the same thing, but come up with a formula. You may have to think of a cylinder. Okay, semi cylinder or something like that. All right. So that's good. That's good. Any other questions for me? Any other questions?
There was a question that I asked in the morning.
Yes.
For the second.
Yes. What was about AI, right? Yeah. So please, he has a question. I would like you to all. Please, can you repeat that? I don't exactly.
So you were telling about if someone is investing into a greenhouse, it has to be a serious concern, and technologically being aware and advanced is very necessary in today's time. So I was asking that AI right now is at the very rapid stage of changing every day. Because earlier, a month ago, like 2 years ago, it had an IQ of an ant, and now it is crossing or matching the average human IQ. So if I today's date I invest a lot of sum into this business, and the next day technology is outdated. So what would you advise on to that part of AI?
Yeah. Yeah. DRL. Have you heard of that? Machine learning, deep reinforcement learning, DRLs. Okay. And one of my collaborators does with me on that. But let me explain something. What is AI? Right? What is AI? Right? That's what I'm trying to explain. in a sort of like a much more simpler way. So let's say you are hired as an assistant professor, right? You finished a PhD. You're finishing a PhD, right?
I'm just going to start it, sir.
You're going to start. Okay, you got 5 years. So who is finishing PhD? You're finished. So she's going. All right, everybody. Okay, whoever is finishing. So let's say one of you becomes an assistant professor. All right, and I'm probably, let's say, head of the department. All right. Okay. So you come to me and I'll tell you, go and teach greenhouse management course to this class. Go and teach. I don't tell anything more than that. Go and teach greenhouse management. So first, what do you need to do? You have not taken greenhouse management course. Now you need to start preparing something. So you are preparing some fundamental information, knowledge about greenhouse management in your mind first. Then you come to the class. You start talking about it. Students are all like this. They're not understanding anything. Let's say that, okay? It's going above heads. You observe that. You see that. You know that. Oh, I'm doing something wrong. So you go back and ask this question. Why it is not making sense to everybody? You make a change. You come back next day. You start doing again. They understand a little bit, not too much. You go back. This is called deep reinforcement learning. The exact thing is being done by the computers. The computers start with background information, background models. The temperature should be this much, light should be this much, nutrients should be this much, relative humidity should be this much. When they are all here, this is going to be the crop yield. These modeling takes a lot of time. What you have to do is you have to take 100 different crops that are grown in greenhouses. And each crop, you should test them at different environmental conditions. 5 to 10 levels of light, 5 to 10 levels of temperature, 5 to 10 levels of nutrients, relative humidity, carbon dioxide. And then you have to come up with a complicated, complex model, a multivariate model that includes all of these variables. And that is the background information. That is the information as an assistant professor you prepared before starting the class. So that takes years, number one. It takes years. Then you come to the class and you are teaching, they are not understanding, so you go back and make changes. If they understand, you get credit. If they don't understand, you're not getting a credit. So you go back and make a change. So you're running loops. It's called loops. The computer runs loops. Test the model, takes the model, tests it. Run through loops and loops. You know how many loops it takes? 30,000, 40,000 loops to even get to a meaningful kind of like a decision support system. For that, you have to test that artificially. Once the testing is done, then that AI is capable. It's not like ChatGPT where you ask a question, it brings out everything, types out for you. No, scientific stuff is a lot more complicated. If you don't do that type of preparatory work initially, those loops will take much longer or the predictions are going to be wrong. When you ask yourself, what is an AI? You are looking at a professor who is perfectly, he knows everything because he or she is going to come and deliver exactly what is needed. That's what AI is. And to become somebody like that, it takes 30, 40 years for a human being. Maybe it's faster for computers, but that background knowledge is not there yet. It is there, but it's in bits and pieces. Over there in somewhere in UK, they have done some research on temperature. Maybe people have done here on nutrients, but their conditions are different. If I take those two models together, there may be an error there. You see the problem? You have to first develop those models, then let the computer take those models, run the models in loops and loops in real world situation to train. This is called training. This is called deep reinforcement learning. This is called training. You are training the computer. If it is a picture, that's a different story. You can take 20, 30,000 images of let's say it's a cat. So how does a computer know? The AI knows that it's a cat. You take 20,000 pictures of different cats and you feed that and train the computer that it's a cat. So computer can take, oh, it's a cat. AI says it's a cat. But that's not what we are trying to do. We are trying to make a decision about optimum environmental conditions in a greenhouse. For that AI should be really, really thorough with not just with background knowledge, but also get trained. We are not there yet. We're not there yet. We put a proposal for that, by the way. the United States Department of Agriculture, and we are trying to create that. We have computer software, we have engineers, we have uh, uh, plant physiologists like me, we sensor guys like me. We are not yet funded, but we are. This is the third year we are asking for the money. If we get funded, maybe we'll do something. Again, keep in mind in research, we always add. It's like a puzzle. You know the puzzle. You put pieces together. We all add puzzles. Some people add a big puzzle. Some people add a smaller puzzle. But when you add a puzzle, it might make much more sense, and you can quickly add 3 or more pieces together. That's what research is. We are all contributing. We are all tiny puzzles. We put things together. Sometimes a puzzle may create a bigger picture that helps all other puzzles to put together, that helps other people to come and do the research. But no one can complete the whole picture by themselves in research, okay? That's research. So we may get there, but it's not there yet. It's not there yet. That is the highest level of decision support systems. People claim, but I challenge them. Where we are then is, I think we can identify pests. I think AI can identify diseases or pests or plants. We are actually trying to train AI with nutrient deficiency symptoms. You will learn about them in the class. This is iron deficiency, this is manganese deficiency, there's zinc deficiency, things like that. But for that, I tried to talk to a computer guy. He said I can do it, but he wanted me to give 20 to 30,000 pictures of deficiencies. So take a plant, iron deficiency, that's one picture. Another plant, iron deficiency, another picture, like with 20,000, 30,000 pictures to train that computer with that. It's not easy. It's a tremendous amount of work. A lot of money should go into it. And I stopped there because I didn't have that much money to run that experiment. So, but anyways, that kind of answers your question. We are heading there. It's not that straightforward. It's not like asking AI to write an essay for you. It's not like asking AI to talk about a person. This is completely, this is called, decision support systems, and they should be perfect. If they make a mistake, the grower is at risk. So anyways, I kind of explained it in a very simple way. DRLs, that's what it is, right? It takes lots and lots of loops.
So rapid progress is going on in the field of these large language models only, like ChatGPT, DeepSeek. They are improving day by day, and still the research portion is still lacking behind.
Because that's what most of the people want. That's where they got money. That's where the common man wants to use AI for. So the more they reach the common people, the more money they have. So the research is, they're not going to get involved into research at all. It will be the responsibility of us. It will be the responsibility of computer software, computer assistant, associate, and full professor in computer sciences, engineering, plant physiology, sensitive. They all should come together. This is going to happen at research stations at university level, not with private companies. It should not happen with private companies, because if they do that, they're going to charge farmers with extreme amount of money for that. If it happens at the university, will make it easily available, affordable to farmers. So there's a big difference, right? I don't think they're even interested in that. They're interested in things that common man is interested. So more people download their software, the more money. If they do something like this, they put $1 million, $2 million into this, and only a few institutes here and there uses this model. So it's not a big money for them. Okay, so it's all end of the day. Yeah. Okay, good. All right, 4:53. 7 more minutes. Any more questions?
Sir, how much it about cost to set up a greenhouse?
Where, in India or in the United States? I'll tell you something I know from India, but I may be wrong. My numbers are.
Standard, we are keeping all the sensors of good quality and all everything good quality. Then what is the estimate?
At some point of time, I was interested in actually building a greenhouse in my. I have a small farm back in southern India, and my brother and I wanted to put a greenhouse. So I got some quotes from a company in Maharashtra, Pune. Seems like Pune has a big manufacturing facility there. So they gave me 16 lakhs for a half-acre greenhouse. It's just a structure, okay, poly-covered greenhouse, just a polyethylene greenhouse. 16 lakhs, half-acre in size, no fan and pad system, just natural ventilation, side and roof ventilation. You'll have a roof ventilation and side ventilation. 16 lakhs per half an acre, maybe 20 lakhs now, 16 to 20. But when you get to fan and pad system, they gave at that time 25 lakhs per half acre, about 50 lakhs per acre. That's the amount of money they asked, though, but three years back, to put a sort of like a half acre greenhouse. Then on top of that, you have to buy benches or the lighting systems, the sensing systems, the plants. Add another 10 10 more lakhs. So you're thinking at 60, 70 lakhs to at least start a 1 acre greenhouse, 60 to 70 lakhs. Okay.
And sir, with that, subsidies also?
Yes, I think there are subsidies. Somebody was telling me, you were telling me about subsidies, right? There are some subsidies, government subsidies, but there are also challenges with that. You are standing in line, you have to probably, I don't know how easy it is. If I apply, I may not get it, but if you are, politically strong, you may get it. I don't know all those things. But there is that, but then afterwards you have to stick with whatever model they are giving. And if you don't like it, especially me, I know the models. I know which models work and I know the limitations because I put 25 years of my career on that. So I may say, I don't want this, and they may say, this is what all we're going to give you. So again, those are the issues, subsidies.
What are the expected profit margins from those?
It depends on the crop you grow. It depends on the time you are harvesting. If you grow tomatoes in same time where the tomatoes are there in the field, like we were talking this morning, you may not even want to harvest them because you won't get even harvesting costs. Field will dominate. Field production will dominate. Field costs are less. There is no initial investment for them other than the ground and tillage and some fertilizers and seeds. You are investing on the structure. You have fixed costs. You have some portion of the profit going towards paying for the fixed costs. So you are at risk when you want to compete with them when they are not producing, or you want to grow crops that they cannot produce in that location.
Sir, one more query. Sir, what about the weed menace in the greenhouse in comparison to the open field?
It's usually very less. Usually very less. I know you're a weed scientist or weed person, but that's why I asked you why greenhouse when you're studying weeds. We don't want weeds in the greenhouse. Of course they'll come, but again keep in mind, I'll talk about peat medium substrates next class. They're all sterilized, a little bit sterilized, so we start with less amount of weeds. We don't want to bring in weeds from outside. It's a confined structure, and whenever you see a few weeds, we'll quickly take care of them. The ground is usually gravelized, so you don't want to even weeds to grow. But I know some greenhouses, they just grow on the ground, they have raised beds and they grow. In such situations, they may have weed problem because the ground has weed population. You just put a greenhouse on top of it doesn't mean that the weeds are going to get killed. So they use mulching, black color mulch, so that black mulch can kill the weeds, and wherever the holes are there, tiny holes, the plants come out. So mulching is one way. You can also apply weedicide and cover it. You are more probably knowledgeable than me on that weeds, but that's one way. We don't want weeds in greenhouses, okay? But if you're growing like a high tunnel where your crop is on the ground, you have raised beds, you may have weed problem. You won't probably use mulches in that sense. Okay. Hi. Any more questions?
Sir, what's the life of the greenhouse?
In terms of different components have different life. For example, the polyethylene sheet, 3 years. The structure, if it's a real good one, it can stand for 20-25 years easily. But what happens is if you put that structure, a poor structure in a windy area, you may get some damage very soon. LED lights may be 7 to 8 years. Okay, cooling pads, probably may want to replace pads by 3rd or 4th year because they get a lot of algae on them, 4 or 5 years maximum. Fans can remain for 5-6 years for sure. So different components have different lifespan. Okay. Any other questions? All right, if there are no questions, we will stop here and I'll see you all tomorrow. Okay. Have a good night and we'll talk tomorrow. I think we are starting substrates tomorrow if I'm not